Our partners in the event today are the Duke University Energy Initiative and the Nicholas Institute for Environmental Policy Solutions. These two signature interdisciplinary units are in the midst of an exciting transition, which is actually a merger. Duke is heightening its commitment to accelerate sustainable and equitable solutions in the climate crisis and to develop a new generation of climate literate thought leaders. An ambitious Duke-wide strategy will build on the university's decades of successful energy and environmental research, education, and external engagement efforts. Working closely with Duke schools and other units, the Merging Institute will help advance the university's climate strategy by developing transformative educational experiences, galvanizing and conducting impactful research, and engaging with decision makers at the global, national, state, and local levels. The new institute will be revealing a new name soon, so keep yourselves posted for that. For today's program called Planet Saving Science, Addressing Climate Change with Sustainable and Energy Materials, we're pleased to welcome two speakers. Helen Hsu-Kim is a professor of environmental engineering at the Pratt School of Engineering. And Megan O'Connor is a PhD alumna who received her PhD in environmental engineering from Duke. And she is the CEO and co-founder of Nth Cycle in Boston. Helen and Megan, welcome to the Forever Learning Institute.
Thank you, Cam.
Great, thank you.
All right, well, thank you. It's exciting to see where everybody is from today. I'm excited to be here with Helen. Helen was on my PhD committee when I was at Pratt a couple of years ago. So I'm excited to tell you all more about the exciting research that Helen's doing and learn more about it. So Helen, I guess first, I think it'd be helpful. Can you tell everyone a little bit about the research that your lab focuses on?
Yeah, thanks, Megan. So everyone, thank you for joining us. So as Cam said, I'm a professor of environmental engineering at Duke, and I've been at Duke for about 15, 16 years. My research area is in environmental chemistry, and as related to materials work, I do a decent amount of work on understanding the environmental impacts of materials that would be unintentionally released to the environment. And also I do research thinking about how do we better source the materials or the raw materials that we need to make modern technologies. So for example, how do we source rare earth elements and other critical metals that we would need to make electronics in our iPhones and things like that. So I kind of work on both the environmental impacts part as well as the resourcing of new materials.
That's great, thank you. And I guess from the students that are doing this work in your lab alongside of you, how are they well prepared, or how does this research prepare them to go out into industry with the different careers that you've seen, at least your students take?
Yeah, so I guess my students, so I teach undergrad students as well as graduate students, and you know, most of the undergrad students I teach are engineers. Some of them are environmental scientists, some of them are chem majors. And what they get from me, I guess, are in the classes, a lot of the fundamentals of how you use chemistry, basics of chemistry in a way that is applicable to environmental issues, including understanding where we get our resources to make, you know, the technologies that we enjoy. And so they take my classes. Some students work in my lab, learning various things hands-on in terms of experiments that we could do. And how does that prepare them for their careers? I think if anything, they get by getting exposed to some of the technical issues of what of some of the problems that might be related to developing new materials or sustainable materials. They get a really good idea of some of the technical issues so that when they enter their careers, some of them are scientists and engineers, some of them are involved in law, some of them are in policy. I think they're just well prepared to having that background so that when they engage in the broader arena, they have that bigger picture in mind.
Yeah, that's great. It's good to hear where all of my fellow peers have gone into their jobs. So I like what you said about sort of the materials that we all rely on for all, like our electric vehicles and our cell phones and things like wind turbines. Could you dive a little bit deeper into that and how your research, really makes a big impact on society? Because I think a lot of people maybe don't realize what all these critical minerals, when they hear material science, they might not make that connection to climate and sustainability.
Yeah, and you're totally right, Megan. So, a lot of the modern devices that we enjoy, like what's on our cell phones, or like the kind of clean energy technologies that hopefully will have a bigger footprint in the future, rely on these materials, on metals that in which the sourcing of it can't be taken for granted. So as an example, like the kind of metals that are used to make the glasses on our the screens on our phones really resistant from scratching entail certain kinds of metals like rare earth elements, in which the way we source it is actually 100% overseas, and for the most part from Asia, from China. And given that strong reliance on this important resource externally, that's created this really uneven market of where we get these metals that we need. And then the other thing is that how we acquire it is can be really environmentally intensive, I'd say, in terms of the impact of mining. So my work has looked at alternative resources for rare earth elements, for critical metals. Specifically, I've looked at how coal ash, coal combustion waste can be a resource for rare earth elements. So I don't know if people in the audience know that, so coal ash are the solid waste that's generated when we burn coal for electricity. And we burn coal for many, many years in the United States and have these waste sites or storage sites that are just basically really large landfills and impoundments of a lot of coal ash. And it happens to be that it's enriched in some of the metals that might be useful, like rare earth elements. So that's like one area that my students and I have done a bit of work on, is just documenting how enriched is this waste in terms of the value of metals, and is there a way we might be able to use it, extract it, and reuse this waste.
Absolutely. And that is near and dear to my heart, as I'm sure we'll talk about in a few minutes, of turning waste products into valuable critical minerals to reuse in manufacturing here in North America. But it's fascinating to think that waste like coal fly ash could be turned into something so valuable. And especially with, I think COVID has strained our supply chains even more. And then all the unfortunate events happening over in Ukraine, I think the critical mineral supply chain has seen even more strain than it had even before, 3 years ago. And so I think it's really important to continue to look for alternative sources, and then even alternative processing methods for the raw or primary materials that we do have here in the States.
Yeah.
So thinking, more broadly about Duke and maybe Pratt in general, where do you think Duke is really distinct in our research and really focused in on and differentiated in the space?
Yeah, I mean, I think where Duke is really strong as a university relative to other universities around the country is that, we're a university where the disciplinary boundary lines are really gray, and such that when we have these big picture ideas and concepts and challenges that we want to address, I feel like we're really good at crossing between different disciplines, so working together on things. So as an example, so I'm an engineer and I work on things like, treatment methods for environmental pollution and things like that. But the issue of how do we deal, or how can we potentially recycle waste materials, is also strongly has an element of governance and policy that's important, in terms of like, well, there's all these policies set in place for how we're supposed to deal with this stuff, but then how do we balance those policies that protect the environment to also help encourage us to reuse it. So I think we have, basically a culture at the university that allows us to sort of cross these boundary lines, and then also programs to support that, like educational programs to bring students along on that.
Yeah. So thinking about that, how did you meet a group of people when you thought of this research direction, or what were sort of sparked this to do this work in your lab in the first place?
Oh yeah. Actually, it was one of my students who came to me, which is awesome. So, at the time, so I don't know when this would have been. This would probably been like 7 or 8 years ago. I mean, you were a student here, Megan. So actually, yeah, you probably know the story. At the time, we were doing research on coal ash disposal, where we're thinking about what are the negative environmental consequences of coal ash itself, because there's also, the toxic metals that are associated with coal ash. And so, my lab had a lot of coal ash samples hanging around. And, one of my students comes to me and says, hey, we have all this coal ash, and I heard it might be enriched in valuable metals like rare earth elements. Can I do a bunch of measurements on them? We have the samples. Like, yeah, go for it. And he ended up analyzing a lot of samples, like more than 100. It turned into this really great data set that was never really established. And so that was how we got started. And from there, we got interested in how do we develop technologies to separate it, things like that. So that's how we got started. So from a student, and a great idea from that student.
I think I know that student. That's great. It's always exciting when, and I did that to my PhD advisor as well. Hey, can I work on this really cool idea?
I think I've heard that story too. Actually, so I'm actually interested to know your origin story, Megan. I mean, how did you get into the work that you did, that you're doing now at EndCycle? I mean, maybe you could talk about your position at EndCycle first, and what you do there.
Sure. So I'm the CEO and one of the co-founders of EndCycle. I started developing the core technology to EndCycle actually in my PhD at Duke. So it came out of a lab there. And it's a new technology to refine these critical minerals that we need for the energy transition. So we recover things like cobalt, nickel, lithium, so the main components of lithium-ion batteries. We also look at rare earth metals, copper, right? All these I call them building blocks of the energy transition, that as Helen mentioned, we simply either don't have enough in terms of supply, or all of our supply comes from, across the world, where it might put us here in North America in a position where, we're very reliant in terms of our national security. And so we work across the supply chain, both with recyclers. So we recycle end-of-life EVs, consumer electronics like cell phones and laptops. And we also work at the front end. Our technology can also help process primary ores in a much more sustainable way. So we can actually reduce the cost and the greenhouse gas emissions by 75% compared to the way that we refine metals today. And so we're trying to create a much more sustainable supply chain as we move forward and try to become leaders in this transition.
That's awesome. What's the I don't know, I guess you don't have to describe in deep detail, but what's the basis of the technology or the products that your company has?
Yeah, so I like to think of it at a really, really high level, like a Britta filter that you have at your home to filter water, right? You have that carbon filter in there, and it removes all the metals at one time as you're filtering out that water from your home tap. We've taken that basic idea, and we have figured out a way to apply an electrical current across that filter to selectively remove one metal versus another. And so we have multiple of these filters in series, and applying a different voltage to each, we can pull out all the different metals individually and recover them in a form that can be directly reused in manufacturing of, say, another battery that goes in a Tesla, for example.
Yeah, that's awesome. I remember that technology. I guess maybe a question I had was, given your experience at Duke as a student, what kinds of things during your time at Duke prepared you to start your own company and pursue this avenue of work?
Yeah, it was I I think a combination of different things. I think similar to what you mentioned about Duke earlier is something I felt as a student as well, is just the sort of cross collaboration of the different disciplines really showed us sort of all of the different areas that really play a part in, you know, any problem we're trying to solve. And in this case, right, climate change, critical mineral supply chains, and working with folks in policy and law, and just even working in, you know, having a peer group from all different backgrounds, right? Like myself, I came from chemistry, but a lot of my peers were, say, from mechanical engineering or biology or from environmental engineering as their undergrad. And so just having that really diverse group of people and thought leadership around me, I think really opened my eyes to all what a technology that you're building in a lab could be. And then I think just the leadership and that I saw, especially in CEE, really inspired me. And I have to say, I was drawn to the program in general from all the female staff there compared to the other programs. So I was quite proud to be a student at Duke and during that time. And so I think a lot of those things. And then you know, I saw the potential in the technology, and we started to run it with real materials from industry. And you know, I said, why not? Like, why can't we do this? And it was a naive thought of a 27-year-old, but 5 years later, we have commercialized the system and are going into our first projects this year with customers. So we're very excited about that.
Oh, that's so awesome. That's so awesome to hear how successful you've been to take basically was the idea that came out of your PhD research into a technology that is being applied and used. And so I think that translation is like, for me, a dream that I don't think I would ever achieve in my own work. So that's really great to hear. So I guess the question I have kind of goes back to the technology and what your company's trying to do. I guess I'm curious to know what you see are some of the big barriers in trying to find alternative resources for some of the critical metals that we need for technologies.
Yeah, I think there's a couple big issues that we face here in North America specifically, because we don't have a great waste management system, especially for things like e-waste, which is typically what my company is looking at. And so, right, if you think about what we all probably do with our iPhone at the end of its life, right? We go get a new iPhone, and most of mine end up in a drawer. I know my parents have like 6 in a drawer, right? There's not a great sort of place to bring that phone. And a lot of states don't even regulate that. Like e-waste, you can still put in a landfill, which is crazy to me. So there's not even any federal regulation on that. And so that's one of the big issues is in terms of sourcing, is just getting consumers aware of and educated on what to do with that waste. Because again, there's a lot of concern around that, especially when you think about the data that's on there and what's done with it, right? Because our practice here for a very long time, recyclers, if I want to do air quotes, were just people who could legally export e-waste overseas. And so now that we're hyper focused on, I think, getting more of the rare earths and cobalt and nickel here, there's more interest in keeping, and there is some regulation to keep the materials here instead of shipping it overseas. So that's definitely one barrier that I think needs to be overcome. And I think we're getting there, but it's a slow process. And then just where, even if the devices are recycled, they end up in very regional or remote areas, and typically like regional facilities, not one big centralized facility out in, let's say, the middle of Ohio, where you might find a big recycling facility out there. So what we have seen in industry is nobody was really paying attention to sort of how these materials were distributed. And that's really what my company decided to focus on, was a distributed technology that can go to these smaller facilities that are actually collecting cell phones and laptops and even EV packs, whether it's a small volume of materials or a very large volume, because e-waste in particular is a very hazardous type of material to ship, right? I think we all remember like the lithium-ion battery videos of they're just like lighting on fire, right, spontaneously. Like you can imagine when big EVs and things reach their end of life, shipping them all in a big truck is very dangerous. And so centralizing operations like that for a big recycling facility doesn't make sense. And so we took the opposite approach of let's go to where the waste is so we can try to access more of those materials. And I think too, even besides e-waste, like the work that you're doing, there's so much of the material out there that has, you know, these high levels, like, I mean, pretty high levels of like rare earth metals. We have lots of primary ore here that has really never been touched because we didn't have the technology and, you know, didn't invest in anything over the past 50 years to actually pull it out of the earth. Granted, like, I don't know if I've seen any sustainable technologies, but that's what we're trying to do of let's, you know, we have to mine these materials, unfortunately, because we don't have enough in circulation yet, but let's figure out a way to do it, you know, in an environmentally friendly way. But I think there's a lot of resources we have here, whether it's end of life waste that we need to turn it into something valuable, or primary ore that we can access with new innovation that makes me excited. I think there is a real potential for us to have the supply chain here that we need.
Yeah. And what you mentioned about the distributed nature of your customers, I guess, I don't know how else to describe it, really rings true to me, because I think about kind of an analogy, at least as an environmental engineer, and how to think about this problem of recycling our waste. Is the analogy is how we deal with water and how do we make and supply potable water for ourselves, and the fact that you know, water is not an unlimited resource in a lot of the country, that we're going into these recycling operations that is changing the way we're treating our water. It's like becoming more distributed. It's not like a city has its own single place and then distributes it to the rest of the city. It's like we have these all like pockets of distribution treatment centers, and the same thing is going to have to happen with solid waste, I guess, in terms of reusing it. So and that means different new technologies that we need to adapt to that. Yeah.
Absolutely. The very traditional method of chemically recycling is these, you know, massive billion-dollar plants that, like, we wouldn't want to put in anyway here because the carbon footprint is horrendous, but it just, you know, you can't get the economics to work with the volumes that we have today, and we need a solution sooner rather than later. So.
Yeah, I think also you mentioned the challenge that is kind of I don't know, social behavioral challenge of like getting used to like, oh wait, thinking about this, like what do we do when we don't want this phone anymore? We want a new one, and thinking about that. And it's, to me, it's kind of ironic because I think about like, we're so used to recycling, you know, our soda cans, we're so used to recycling plastic, which really doesn't really get recycled. And the thing is that like, it's not as automatic when we think about the electronics that we buy and things like that. So there's still a bit of ways to sort of translate that thought process to other things that we consume and then end up throwing away.
Absolutely. And I think a lot of thought needs to be put into this. And I think there is some, especially over in Europe, at least, of, you know, electric vehicles are just a much larger form of e-waste. And I don't think people realize that, like, what are consumers going to do with these electric vehicles when they can no longer drive them, or they don't want to replace the battery? And so the car is essentially, you know, not usable. Because the OEMs, once they, the folks who are manufacturing these, once they sell them, you know, they don't have any responsibility. And so there's an interesting trend happening over in Europe where the OEMs are being forced to actually take ownership of the EVs throughout their entire life, so that they are sort of forced or incentivized to figure out what to do with these cars, because, you know, we can't have just electric vehicles piling up in people's you know, driveways like you think of right in the drawers. So
I mean, the lifetime, or at least the lifetime of the battery in EVs are shorter than the typical lifetime of a car itself, right? That like a regular gas combustion car.
Yes, definitely.
So it's not, and I don't know if that's a technical design that we can overcome in terms of extending the lifetime, but it is then going to mean that those kind of parts are going to pile up quite a bit. So yeah.
Exactly. And a lot of talk around, can you take it like you would go to get your oil change? Can you pull in and have that battery pulled out and another one put in? Right now, that's a no, but you know, that would be ideal for not just convenience, but also the recycling part of it as well, making it easy to access those materials once they're pulled out.
Yeah, and I think you know, that the transition to electric, you know, electrifying our vehicle, all the cars, I think it's really just going to get faster and faster. So I can see that problem coming up very quickly. The pile up car waste as e-waste.
Mhm.
Yeah. So I guess another question I had was, were there any special, like when you're a student at Duke? So I realized it was a few years ago, but when you're a student at Duke, were there certain programs or activities that you found yourself that you feel like it was really valuable for you and what you do on, in your job now?
Yeah, I think one of the most valuable programs that at least I attended lots of their luncheons, and of course I'm blanking on the name now, but they hosted folks from different industries to show you the different career paths that you could take. And so they tried to bring in people, like I remember it was a textbook writer in science, like who got her PhD. The power lunches is what they're called. Thank you, Cam. And I just remember like that was never something I would have thought of as a career path. Because when I went in, I wasn't like, oh, I'm going to be an entrepreneur. Like, no, I was not. I had no idea when I came to get my PhD what I wanted to do at the end of my 5 years. But it was just fascinating to see all of the different career paths that people have taken after getting their PhDs and how much cool science goes into so many different disciplines. So I think that was a very unique program and feature that Duke had that I thought was really valuable as somebody that came in and wasn't necessarily sure what I wanted to do afterwards. So I really appreciated those and just the vastly different folks that they were able to get in on panels to give talks. It was a nice variety.
Yeah, that's cool. I want to do the power lunch. I guess
It's fun. It was really fun.
It's probably good that it's student only. It's probably good.
Let me jump in here with one of the questions that has come in through the chat, and it came in pretty early on, Helen, when you were describing your work. So I'm hoping that you'll understand the reference for the question. It says, do you evaluate the economic viability of these options or leave that to the free market, so to speak?
Yeah, so that's a question I get all the time, and I was actually anticipating it because it's very common. So I'm assuming that the question was referring to when I was talking about my work, looking at rare earth elements and coal ash as a potential resource for these valuable metals. And we've done some calculations in terms of what's the economic viability in terms of the costs of the separation technologies that you'd have to use, and all the waste that you would end up generating in that, and then what the market value of the final product would be. So I would say very preliminary calculations on the economic. It's basically a techno-economic assessment. And what I've learned, and also just from reading the literature and listening to other researchers who work on the same thing in terms of recycling coal ash for rare earth elements, is that to make coal ash a viable resource for rare earth elements, the process will actually have to find multiple products that you get out of recycling that coal ash other than rare earth elements. Like, for example, coal ash, if it's of a certain quality, can be used for constructing building materials like concrete and things like that, but it just needs to be of a certain quality. So you can take coal ash and put it through various types of processing to extract out valuable metals, but also raw materials for concrete and other things. That's when the viability then becomes something that is worth pursuing. It's just kind of my thoughts there.
I am interested in both of you talking about any aha moments that you've had. So Megan, you said you never thought about being an entrepreneur. Where was that aha moment? Helen, whether you've had it in your lab or in a classroom. So Megan, you want to go first?
Sure. Yeah, it's kind of, it goes back to like how I figured out I wanted to even start EndCycle. So I had been working actually on a completely different project for the first 3 years of my PhD work, and didn't really love the industry that I was in at the time, working in, I should say, for that project. So I started digging into all the literature on critical materials, and it's probably tied to Helen's student somehow, I imagine, the rare earth side of things, because we were friends. But we all got very fascinated with critical minerals, and I kept digging in more and more into literature and kept seeing these projections that we simply were not going to have enough. And on top of that supply deficit was the fact that all of these materials were overseas. And so you can just imagine the chaos that would ensue, right? If we had a big supply deficit and then everything is overseas for us. So I kept looking and seeing all these, fabulous articles in the media about this transition to clean energy and away from fossil, but I didn't really see anything in, mainstream media about the supply demand issue. And I was like, this has got to be a real issue that industry's thinking about, but they just don't want to say it. So I actually found my way into it's called the Green Electronics Summit that was hosted at the university. And it was folks from like Apple, Dell, Intel, and they were all invited by a professor to come. And I had to be in that meeting, and it was closed to students because it was really just the professor focused on learning what their sustainability issues were long-term so that they could help direct the research there. And I banged on this professor's door for about 3 weeks straight. So I could get in that meeting, and he finally let me in as a scribe. So I sat there taking notes for, 9 hours or whatever it was, because I couldn't even bring my laptop in, but I had to be in there to see if industry was also really, really worried. Because one of the main reasons I came to Duke in particular was because of their research that was specifically focused on industry, right? Solving real industrial problems. And so over and over again in this meeting, I kept hearing, the waste management problem was top of mind, but they had no idea how to solve it because recycling technologies were too expensive. And so they didn't want to invest in those, but knew they had to figure out a way to do that over the next 5 to 10 years. And then supply chain was sort of paired with that. Those are like their top 2 issues that they were super worried about, especially, and these were like consumer electronics companies, right? So you can imagine how worried they were with EVs that use orders of magnitude more cobalt and nickel, for example, in their battery packs than you would see in a cell phone. So I walked into that meeting and thought, like, I can figure out a way to recycle these materials in a form that can be reused directly. Again, my young PhD brain. And so I walked into my advisor, who is Desiree Plata's office, and asked her if I could work on that. And that's sort of where the idea for the technology for that application came from. And then, 3 years later, we got the technology to work. And that's really where EndCycle came from, is I wanted to take it out and see what we could make of it and commercialize it, because I saw so much potential. So that was sort of my aha moment of, digging into the literature and then talking to some industry folks and seeing that it was a real problem that, I could hopefully have a real impact on.
And that professor who convened the Green Electronics Summit, where was his or her home school or institute?
So I was a visiting student up at Yale at the time. And so it was up there when I was visiting for part of my PhD work.
Oh, well, that's enough about that. We don't need to hear about that other school. Anyway, just kidding. Thank you. Helen, how about your aha moment?
I guess I had a couple, I guess. Well, one is, what got me into what I do, which is becoming an environmental chemist. It was definitely my experience as an undergraduate student doing research in a professor's lab. I was working in an environmental engineering lab, but the professor was a microbiologist, actually phytoplankton, algae. And so I worked in her lab for a year, and we looked at how algae take up metals from their environment. And the aha moment was I was really bad at growing these things. I was really bad at taking care of living organisms in the lab. And so that was my aha moment, because I was like, I'm bad at that, but I understand the chemistry. So I'm going to do the chemistry. And that's how I ended up becoming an environmental chemist, environmental engineer. But the other aha moment was basically, as I mentioned before, my grad student coming to me and saying, hey, we have all this waste material around. Can I look at it for the flip side of how we might reuse it? And I was thinking, yeah, I'm so tired of thinking of waste as being bad all the time. I want to make something positive out of this. And so that was the other moment. I was like, we gotta flip and rethink how we're doing our work. That actually is more than just telling people about problems, but also helping to come up with ways to resolve those problems.
So everybody on this call knows that the climate crisis is a huge issue for everyone in society, and Duke has strength across the entire university, which is why we're coming at it from a university-wide approach. How is your research and your work, how do you think it's going to have impact on our climate crisis?
Yeah, I guess I can go first. So yeah, I mean, my work looks at how we might better, as we develop technologies to address our climate crisis, for example, finding different ways that we better cleaner sources of energy, for example. My work thinks, like in my group thinks about, okay, given these technologies, or how do we better design technologies that account for how we're resourcing things, and what that resourcing would mean for impacts that we don't necessarily anticipate. So for example, I also do work on the impacts of gold mining around the world. And gold is one of those metals, so it's a precious metal, but it's also a metal that's needed in a lot of our electronics. And so the demand for it has always been very high. And a lot of the gold that we get around the world comes from these illegal or small scale mining operations. And that has a tremendous environmental impact. I do this work in Latin America, where illegal gold mining kind of comes hand in hand with deforestation of the Amazon tropical rainforest. And so, that the issue of resourcing materials for technologies and the climate issue is like it's all related, because there's ecosystem impacts that have effect on the climate, but also that we're resourcing these metals. So I see it as all being interconnected in many different ways. That is more than just, oh, we're just going to make metal, we're just going to make a better battery for our cars. It's more than just that. That's kind of how I see it.
Megan, you have a response?
Yeah, very, very similarly, EndCycle's mission is to create just more of these materials, because we do not have enough critical minerals to make the transition. And I don't think people realize that. I think what we have today in terms of nickel is about 10% of what we need to reach our electrification goals in just 10 years. So there is a very long way to go for us to get there. And I think we have a particularly large pain point here in the States, as Helen mentioned, just because we don't produce any here. I mean, we had one nickel mine and it's on its way out. So we need to find alternative sources. So secondary use of waste is an amazing thing to be researching. So I'm always excited to see the different work that comes out of Helen's lab. And then, all of the great innovations coming out in the space. And then figuring out a way to process primary ore here, because a lot of people say, not in my backyard. But, we have to do it in your backyard. Well, let's do it in a much better way, right? Let's figure out a new technology, a more sustainable path, so that we can mine these materials and not damage the environment in the same sort of step. Because unfortunately, to get to the clean energy transition, or the clean energy economy, I should say, we have to have those materials, because that's what all of our technologies rely on. And so that's really what my company is trying to do, is provide those materials, and not just provide the materials that go into clean energy technologies, but provide them and have them have a much lower carbon footprint. Because I don't think people realize how horrible the processes are around the world that currently give us, as Helen said, for gold. I mean, it's very similar for cobalt, with the artisanal mining, they call it, over in the Democratic Republic of Congo, where there's literally children mining cobalt out of the ground. And that's where 65% of our cobalt comes from around the world. So practices like that happen for a lot of these materials, unfortunately. And so there's I think a big opportunity for us to figure out a better way to get these materials. And so I'm excited for the work that is happening in the space. I think there's a lot of room, to move us towards our climate goals.
So I'm going to ask one more question, and then I hope that the participants will light up the chat with their questions. But obviously, it's going to take more than a village to help us make some impact on this climate crisis. And how can your research and your work be used at the household level? How can everybody help with this? I had an ad the other day that I am not remembering who it came from, and it told what to do with that old iPhone and what to do with those.
I was going to say, yeah, I think everybody as a consumer, and even myself, right? I'm guilty of it too, of, figuring out where to actually bring your e-waste and properly dispose of it is a huge, huge, huge part. Getting those secondary sources back, as I call them, to a place where they can be recycled, I think is definitely something you can do every day.
Yeah, I mean, for me, if I'm in the market of needing to get a computer, I am insistent on it needs to be something that I could replace its components. Because I think it's, if something is fine, except it just needs a new hard drive, or, I think it's silly that we have to, a lot of them are hardwired in that you can't just replace components anymore. So it's like, I think like the kind of choices we make as consumers, I think is probably the main thing, or one thing that I think we could easily, keep tabs on for sure.
So I'm not seeing questions in the chat yet, so I'll ask another one. And no, here's the chat question. How can we tell if the e-waste recycling program in our community is handling these materials in a responsible way?
That is a really, really good question. It is unfortunately not easy to figure out, even from the customer or like the company side. A lot of folks who are doing responsible practices will post it on their website, or will have some kind of report that they post. And so you can typically take a look at that and see actually what they do with the e-waste once they collect it.
Yeah, I wonder, I have the same question for me. Because, around here, like in Durham, the Raleigh-Durham area, there, the municipalities have, places where you could drop off, or places or events of collection. But I wonder a lot if this is just, this is the way where we could throw away things, but it just doesn't go into a regular landfill. It goes into one that is for dealing with hazardous waste. And I do wonder if it really is getting recycled. I doubt it. It's hard to know. It's definitely hard to know. So I don't know the answer to the question of how do you tell what happens. I had the same one.
It's super hard to know. And I'm actually curious if Duke has some kind of electronics recycling program, because usually like big universities or big companies do partner with folks who are recycling it further than just, bringing it to a separate landfill for e-waste.
I don't know. Do you know, Kim?
I don't, but Katie Douglas put in the chat, Fairphone is a smartphone company designed for longevity. Well, maybe that's not, well, we can certainly find it out, and we will let everybody know after we ask that question, but it would make sense for sure. So what do you think is the next frontier for research, business, education in this area?
Well, I could say the research part. So there's, over the last maybe 10 years or so, there's definitely been really great advancements in the material science area in terms of developing new materials that are finely tuned for certain reasons, and really just really a lot of advancement there. What I think is where that's going to go in the future, where I think it should go, is actually fine-tuning new materials with consideration of how we're going to get those materials. And I think and I think that part of the question is really kind of ripe for picking in terms of for researchers. The whole like materials genome initiative, actually delving into where are we getting these materials that we're characterizing so well and fine-tuning so well. So that's where I'm hoping, and having that translate to, at least at Duke, the educational programs that we offer, like our material science and engineering degrees, that's for graduate students, or certificates that we could offer to undergrad students at Duke.
Megan, do you have a business answer? or another answer?
I would say, I mean, waste management in general, at least in the space that I'm in, is a very, very new market. I mean, it's a tiny nascent thing that, because for a very long time, I mean, people have recycled lead acid batteries here for a long time, but never lithium ion. And so, you know, I hope we're at the forefront. that's the timing that we're targeting. But I think there's still so much interesting innovation and room for innovation in this space. Like, for example, I come in at a stage after the batteries have been collected and disassembled to a certain point, and then my company chemically recycles those parts. But all those parts are manually disassembled by a human. So think about these big EV packs come in, and somebody is literally sitting there discharging it, taking out all the cells and the modules and, you know, all the levels down to get to the thing that I actually then chemically recycle. So I don't know if anybody's working out there. I have not seen anything, but I think that'd be an amazing research project of how do we automate that, right? Because you can imagine the bottleneck that will occur when we have thousands, if not millions of EVs coming off the road every year. You know, we cannot continue to use people to do that. So I see that as a really interesting research area that I would gladly take a look at from the company perspective as well.
Yeah, I think I kind of wonder if the companies that make these devices kind of retain the responsibility, like you were mentioning this before about what's in Europe in the cars, that they would be designed in a way to be easily disassembled. That's like, I feel like that's what we're missing.
Yes.
Like that built into the design of the product is that, oh yeah, and we also have to disassemble it when we're done with it. That would help with all these things that you're talking about, the labor involved.
So the chat's getting a little more active as we come up on the end of this. I'm just going to take some questions in order. I think this one is for you, Megan. Do you see your company ever growing a consulting arm on potentially advising companies on how to recycle or recover things like battery electrolyte?
Yeah, that's a really good question. We kind of do that as part of our sales process now. A lot of the companies and customers that we work with are folks who have sort of been in that position I mentioned before, where they've collected and been on the logistics side of waste management for a very long time. But the only solution that they saw and the only place they would or what they would do with those materials is sell them over into China or into India, right? And now that there's a bigger push to keep those materials here, and there's actually regulation that we can't ship as much overseas anymore, they're starting to figure out or want to figure out what to do with those materials. And so we sort of educate them on, you know, what to do and how to recycle those different components that they've never had to think about chemically recycling before. It's an interesting question. I don't know if we'd ever have an arm of that, but we definitely do that in our you know, everyday business sales pitch.
So Megan, here's another question, or it's pretty specific. Can you discuss more details about EndCycle's electro extraction process?
Sure. I don't know how much detail to go in, so I'd be happy to jump offline if anyone, I don't know who asked that question, wants to talk further. But in general, the process is combining some of the different steps that we see in traditional processing today. So for example, the way that they chemically process materials today overseas is they dissolve everything in acid, and then they use chemical precipitation followed by an electrochemical process to pull these different materials out. All of those different stages with the heavy chemical use is very carbon intensive and just very expensive in general. And as I mentioned before, these facilities cost $500 million, if not $1 billion to set up. We never invested in any of that here in North America. We've always done it overseas. And now that we want to do it here, we're struggling with how to chemically process those. So electro extraction combines three of those processes to not only shorten the process, but to also reduce that massive chemical load that you need to pull these materials out. So instead of using harsh chemicals or high temperatures and pressures, we use a very low amount of electricity to pull these out. And so that's I guess a more technical answer. Like I said, I'd be happy to talk more in detail about where we fit in the supply chain and things. If again, I don't know who asked, but happy to talk more offline about that.
Great. Thank you.
And in my lab, we've been looking at how we might use membranes as a separation instead of electrochemical separations. That's what EndCycle has, pioneered that technology, that approach. We're using what's called supported liquid membranes, which is really using chemical organic solvents. That's actually what's usually used at a rare earth mine. but actually putting those solvents into a solid membrane so that you can basically make a filter to selectively filter out like rare earth elements from the feed. And the reason why you would do this is that you then don't need so much solvent, like which are hazardous materials usually for the process. So it's hopefully better in terms of chemical intensity that we have to use. And then also we could, use these in these distributed locations, like the recycling facilities that will be small in operation, but many across the country. So we can do that with membranes.
Can you describe any emerging technologies applied to resource recovery from varied waste streams?
Very well. Okay, so I described the conventional approach as using organic solvents like kerosene, which is usually at like big mines, right, Megan? Like your traditional mine. But there is a push to try to go smaller scale and less chemically intensive, like using less organic solvents, using less acids, using things like membranes or electrodeposition type. Yeah, I mean, Megan, yours is really like membrane and electrodeposition at the same time, right? Yeah. Using the special resins to capture the metals. It's usually a variety of those things that allow for a smaller footprint and kind of more modular design. Those are usually the technologies I see. I don't know, Megan, do you have any thoughts on that?
You say as an emerging technology company.
Yeah.
Yes, I think what Helen said is correct. You see a variety of companies in the space emerging, right? As I mentioned before, lithium-ion battery recycling is a very, very new market. And there's big startup companies are coming out in the space besides mine. And there's sort of a battle between like, is the centralized, vertical integration approach going to work, or is this distributed model that EndCycle is using with innovative technology going to work? I think there's room for both. I think it's just, I've seen more push in the sort of regional, because that's where our waste ends up. People are not going to want to ship it, and it's going to be very difficult to get the materials from place to place to get it into a centralized facility. So that's a lot of the technologies I'm seeing, like Helen mentioned, are modular, less chemicals, right? We have very strict environmental regulations here compared to overseas. And so we can't use the technology that they have or have used in the past, which I think is a good thing, right? It pushes us towards innovation and to think a little bit differently and more creatively. So those are the types of sort of innovative new technology that I'm seeing in the space.
I'm going to go to a different question asker in the chat. So are you also considering research and use of technologies in oil field water waste and acid mine drainage waste streams?
For me or for Megan?
I think it's to both of you.
So we are definitely looking into acid mine drainage. I have a student now who's looking at how we might use our membranes on acid mine drainage in the eastern part of the United States, where there's also enrichment of rare earth elements in these mine drainage streams. So that is one that we're looking at. We haven't thought a lot about like wastewater from oil and gas, mostly because we just haven't had the bandwidth to expand into there, but that is a potential as well.
Okay. And great, Megan, thank you. You answered the last question in the chat by responding on your own. So that's terrific. Thank you. So this has been a wonderful discussion. I hope everybody who has been listening in is proud of Duke for its faculty, its students, its research, its entrepreneurship. This is just a wonderful and very small example of all the work that goes on at Duke in materials. There's also a materials initiative, and I think we'll put that link in the chat. And so Helen is probably part of that very large group of faculty who work on different kinds of materials. Some work on biomaterials, some work in the same place that Helen does. So that is a wonderful website to look at to see both the breadth and depth of the research and the education and the work that's going on at Duke. So I want to just close out by saying thank you so much to Helen and to Megan for being with us today. Thank you to our co-sponsors of the Duke Energy Initiative and the Nicholas Institute for Environmental Policy Solutions. This was recorded today, and we will pass it along. You will have a recording and you can pass it to other friends as well. And our next session is actually going to be today in a couple of hours at 3 o'clock as we continue exploring sustainable and energy materials. And please check out the robust course syllabus that is posted on the Forever Learning Institute website. We look forward to seeing you at our next offering. And again, thank you to Helen and Megan. Go Duke.